First of all, thank you, Erdem Taylan, for the wonderful speech. And now our next speaker has given all his dedication and hard work to the field of medicine. Because of that, he has received many research awards, starting from the European Association for Neurosurgery, American Association for Neurosurgery, Turkish Brain Research Association, and Turkish Neurosurgical Society Award. And last but not the least, he received one from his students, the most important one, as he says. Moreover, he established the first tumor bank in Turkey. He has performed 600 surgeries, treated over 1,000 patients by using gamma knife therapy, and consults around 3,000 patients annually. Now, it's time to learn what's next in field of neuroscience. So, ladies and gentlemen, the founding dean of Sabanci University Medical School, Operator Dr. Turker Kilic.
Teşekkürler. Erdem very beautifully showed us that in the era that we are living in, we cannot determine where the imaginative world ends and where the reality starts. But 3 years ago, I was in the operating room and I was taking out a tumor. So I will tell you about something about the hardcore real life. But once anything is in our mind, it doesn't matter if it is a real thing or if it is an imaginative thing. It is a mind thing. So this is something different. And I will try to give you an idea about the next step in brain surgery, which is called connectome surgery. Connectome is the term for the whole network of information created in the brain. The connectome is a kind of interface between the brain and the mind. I'm a brain surgeon, as I said, who is changing the anatomy of at least 4 human brains daily. My curiosity is, how does this flesh of tissue create the function of thinking? How does the brain form the mind? And I think there is a relation between brain and the mind, like as once Aristotle said, eye and vision. And what I learned throughout my career is the important thing or event is not the thing or event itself. What really matters is the network or the connections that the thing is intermingled in, the connectome. Our collection of genes, defined in 2003 by the Human Genome Project, most of us thought that this genome map would give the reasons of genetic diseases at least. But soon it was realized that this was not the case, because it wasn't the genes what really matters, but the physiological connections, the physiological network between them. Now, we call the genome to the total functional network among these 22,000 genes. Like the 22,000 genes in the genome, 100 billion neurons in the brain, each connecting 10,000 other neurons, form the functional network of brain called the connectome. The probabilistic variability created by these 100 billion of neurons, each connecting other 10,000 neurons, is not only unimaginable, but also is not mathematically figurable by our current computer technology, and most probably will be only figurable in the coming decades. I would like to take your attention to these creatures. Genetically speaking, 95% of their genomes are identical. What makes the difference is only 2%. So we can say that it is not the anatomical genetic structure of these creatures make them different, but the physiological, the connections of their genes make them different. Information flows in the connectome, like the branches of Amazon River seen by the plane. As the pattern of this river network changes, the electrochemical information flow in the connectome changes. This can be done in time from one to other individual. This ever-changing potential of connectome, which can also be named as Neuromind, is called plasticity. Plasticity is the basis of learning. So by this plasticity potential of our brains, learning can only be possible with. The relation between one aeroplane and the airline company is an analogy of the relation between one neuron and the connectome. It is not the total collection of airplanes that constitutes the airline company, but the entirety of all flights and the connections. Before moving to the complex human connectome, let's talk about the simple creature, a worm called C. elegans. The connectome of this worm consists around 300 neurons. Look at this connectome map of this worm, resembling a flight map of an airline company. Please get an insight of how complex and human connectome having 100 billion neurons. When you compare this network of consisting 300 neurons, here you see each of these neurons of this simpler creature, which is a worm. So scientists for the last 20 years identified each neuron intermingled in this informative process. So this connectome makes this worm to make the choices. So when you define consciousness as the ability to make choices, then we should notice that this form, the connectome of 300 neurons, is conscious. Even though we are far from displaying all of the connections among individual neurons yet, we can visualize radiographically or anatomically dissect the brain, the connections between the hubs, the functional centers of the brain. This image is got from our laboratory. This is a cadaveric brain dissection. And here we got this today in the laboratory, in the operating room with this intraoperative MRI. You see the interconnection between these fibers, between two hemispheres. This is the radiological image, and this is the dissection we have derived from cadaveric dissections in the lab, in the anatomical lab. Even though we are far from displaying all of the connections among individual neurons yet, we can visualize radiography all of them. I hope this animation gives you an idea about the primitive visualization of human connectome. Here we see the artificial map of connectome formed by the hypothetical connections between the functional centers of the brain. As we cannot define each of the neurons, for example, we can link this hub in the brain to another functional unit. So we can draw a hypothetical map of the connectome. An anatomical damage in the structure of the brain is like a mutation in the genome. But one functional change in the connectome without any anatomical alteration in the neurons is like the difference in each of identical twins, raised in different environment or circumstances. So, main thing what makes different people different is their connectomes. In fact, every biological organism which is producing a kind of biological information signal is capable of creating a kind of bio-knowledge connectome, potentially capable of making choices, that is showing signs of consciousness. For example, in one of our recent science papers, we showed the differences in the bioconnectome of the meningiomas, a kind of neoplastic tissue originating from the meninges of the brain. So even the neoplastic cells has a kind of connectome produced by the bioconnectivity in this neoplastic tissue. I think now you have an idea of a connectome. Now I would like to take you on two different thought routes. One of them is the physiological connection of the neuron, brain, connectome, and mind. And second is the linkage between the brain surgery and the connectome surgery. Let's start with the first one, and remember our analogy of eye and vision to brain and mind. The brain is the organ that constructs the mind. I would like to repeat this sentence. The brain is the organ that constructs the mind. The flash of neuronal tissue forms the mind through the information network of connectome. Similarly, the total network of all minds, the total network of all minds, the connectomes, forms the whole life. Probably the greatest sum of all minds is the life itself. Each of us is living in our own mind. Total sum of minds forming the life. Probably there is a kind of connection between one's mind and the life itself. So let's answer the question. How does connectome surgery potentially change the life of a patient or a normal human being? Functional neurosurgery is a field of brain surgery that aims to change the interaction of neurons instead of anatomy to create a functional change. Parkinson's disease is a simple example that can be treated by functional neurosurgery. In Parkinson's disease, the neurons do not have an anatomical problem. However, if you change the connections by the help of a battery here, if you change the connections among a group of neurons, in effect you change the connectopathic part of the patient's brain that causes the disease. So the question for future is, if one day we can map the entire human connectome, like we can map the connectome of the worm, just as we can cure Parkinson's connectopathy, can connectome surgery fix pathological behavior, or more importantly, can we make normal mind better, more creative, for example? So connectome surgery has the potential capability of changing the plasticity of mind, that is, changing the life. We don't know the answers to these questions yet, but I would like to leave you with these three messages. First, human beings are their connectomes. Second, these connectomes can be changed by education or by connectome surgery. Third, life is a total sum of connectomes of all beings. Please never forget that. Brain is the mind organ. So if there is an interface between the neural network and the mind, and if this interface is called the connectome, and if we can change this connectome by neurosurgery, this in turn changes mind, and this in turn changes life. So I would like to take your attention to the word of connectome, and I think we are now, for the first time, using the word of connectome surgery in the neurosurgical literature. Thank you.